Welcome back. So we're going to continue our discussion of the fundamental theorem. And again, all we're doing is we're finding area. For example, this is just the square root 3 times the square root of x. So it's going to look something like this. We want to find the area from 1 to 4. So we're just looking at this little piece of area right there is what we want to find. And unfortunately, there's no really geometric formula that can give me that area without going crazy. So we're going to use the definite integral. And I don't like that square root of x, so I'm going to rewrite it as x to the 1/2. 3x to the 1/2 dx. When we integrate this one, we would get 3x. Be careful, this becomes to the 3/2, and we're going to multiply that by 2/3. Again, I can put the plus c if I want to, but when I evaluate it, it's just going to cancel anyways. So I don't necessarily need that. The 3's here cancel, and I'm going to go and rewrite this as 2x to the 3/2 from 1 to 4. When we apply the FTC, f of 4 minus f of 1, remember, we're looking for the change in the y value of the function. If this is my derivative, this is my function. I'm just looking for that change in those y values, how much those y values are increased. And again, that's the reason why c really doesn't matter. If we think of c as the y-intercept, like here's my y-axis, if here's c1, it doesn't matter where I begin. There's my change in my y. That's what we're given here. We're just looking for the change in y values. It doesn't matter if c1 starts here or if we start c1 here, the change in y will always be the same. And that's another way to look at that constant doesn't really matter for us right there. So anyways, if we plug in the 4, we're going to get 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Now, we do expect you to be able to simplify it. The second one's easy. That's just 2, because 1 to the 3/2. But over here, we get 2 times, we should simplify this one. The square root of 4 is 2. We just take the root. We do the root first. The square root of 4 is 2. 2 cubed is 8. And you can leave it like this. That's even better looking at. Or you can make it 14 if you like. That's 16 minus 2. But we do expect you to be able to simplify easy exponentials like that. For a question like number 5, remember there is no product rule. There's a chain rule. We'll talk about that in a few days. So for a problem like number 5, we are going to have to expand it. If I expand this one, this becomes 3x squared plus 3x minus 2x, so plus x minus 2 dx. So we have this parabola that we want to find the area under. So my rule says to integrate it, take the antiderivative, add 1, we get x cubed plus x squared over 2 minus 2x. And again, I don't need that plus c there, so I'm going to evaluate this from negative 1 to 4 here. And we're just going to apply the FTC. F of 4 minus f of negative 1. Big parentheses. We're not going to simplify a little bit. 4 cubed, we should know what 4 cubed is. That's 64. We do want to write that. Plus 8 squared is 4 squared is 16. 16 over 2. Nobody knows what that is. Minus 4 times 2, which is 8. So 4 times 2 is 8. So I'm just plugging these in. I'm plugging each of those in. I'm plugging each of them in. Plug in negative 1. Negative 1 to the 3rd is negative 1. Negative 1 squared is 1, so that becomes minus 1, or plus 1/2, excuse me. And then if I plug in the negative here, negative 2 times the negative 1, we get plus 2. There is your final answer. Don't simplify that, just leave it alone. It'll take you longer to simplify it than to get the actual answer itself. We're done. Move on. So let's see how this works for us. Let's say we want to find the area bounded by this parabola, the x-axis, x equals 0 and x equals 2. So we want to find the area underneath here, this little shaded region right here. Now again, I really can't do it unless I do calculus. The only way to do this is calculus. We need calculus to get the area here. Because I can't use a Riemann sum, it won't work out very nice for us. So to get the area, our rule says to integrate our bounds, x goes from 0 to 2. That's what this is really saying. X is going to go from 0 to x equals 2. Everything's in terms of x on my x-axis. And Later on, we'll get more complicated, but we always want to measure to the x-axis. And this just becomes 2x squared minus 3x plus 2. Now, they're not going to tell you to do this, but we're going to use a dx. But we should remember, that comes from our Riemann sums, if you forgot. Remember dx and f of x. That dx comes from our Riemann sum. So our rule here, integrate. We're going to get 2/3 x, whoops, that's a weird looking 2 there on top. 2/3 x cubed minus 3/2 x squared plus 2x. We're going to evaluate that from 0 to 2. And now we just do the FTC. This is f of 2 minus f of 0. Big parentheses here. Plugging in a 2, we're going to get 2/3. 2 cubed is just 8. Minus 3/2. 2 squared is 4, so times 4. Plus 2 times 2 is 4. Plug in 0, 0, 0, 0. So 0 minus 0 plus 0. Let me go ahead and fix that, make it look a little bit nicer there. And again, that's just all 0. Whoops, didn't want to cancel all that out. There we go. That's all just 0. So there's our area, and the exact area. And that's what's really, whoa, hello. And that's what's really cool about this. We showed above that this gives us the exact area. We kind of showed an example to prove it right here. And there it was. That gave us the exact area of our triangle, which we saw in our first example. So we know that this is going to give us the exact area right here. All right. So you guys go and try number 7 here real quick. And I'm going to go and do it. You can pause the video, try number 7, and I'm going to do it right now. To get the area, we're going to integrate negative x squared plus 4x. They're not going to tell you dx. Now, but be careful. They didn't tell me where it starts. So they don't give me my bounds. I am missing my bounds here. So we got to find them. One, I could look at the graph that I'm given. But if not, we can always solve it. Just set your function. Since we're going to measure to the x-axis right here, just set your function equal to 0. And you get x equals 0 and 4. So I can put those in my bounds. Remember, these are my x values. That becomes important for us later on. Okay? All right, so when we integrate this, now, we're going to get negative x cubed over 3 plus 2x squared. Again, we don't need to put the plus c here. This is a definite integral. So definite integrals, we say we don't put the plus c. We evaluate that from 0 to 4. Using our FTC, f of 4 minus f of 0. Remember, what we're really doing here is we're finding the change in our y values of our original function. So this right here is a derivative. What we're trying to do is find a change in the y values of the function itself. Plugging in the 4, we're going to get negative 4 cubed is 64 over 3 plus 2 times 16. Plugging in the 0, again, you're going to like zeros in here. That just becomes 0. We don't worry about that. And there is our area. Now, there are some functions that we just sketch. And we're going to talk about. A prime example is always absolute value. The other one we're going to talk about later on is called the circle. So for absolute value, we're going to sketch it. It is a lot easier to do absolute value sketching than it is to integrate it. It's very nasty to integrate. Absolute value is very easy to do. This gives me my vertex. My y value, my vertex here is going to be 0, but this is a horizontal shift to the right 3. So we're at 3, 0. Graphing it, there it is. We want to find the area from 0 to 5. And if you notice, it's just 2 triangles. So our area is just the area of 2 triangles, which is 1/2 base times height. So if we do the first one, 1/2. The base here is 3. The height, if I plug in 0, is also going to be 3. Plus, the second one, the base here is 2. And the height, if I plug in 5 up here, 5 minus 3 is 2. Of course, that's going to cancel. And what we're left with is 9 over 2 plus 2. Don't ever simplify, just leave it alone. So go and try number 9 here. We want to try this one. We're going to bring this power up. So if we were to integrate it, remember, we're going to write this as x to the negative 3 dx. Integrating it, adding 1, we get x to the negative 2 over negative 2, or negative 1 over 2 x squared. We don't like the negative exponent. We evaluate that from 1 to 2. Using your FTC, f of 2 minus f of 1. Plugging in the 2, we get negative 1 over 2. Square it, we get times 4 minus a negative 1 over 2 times 1. Now, normally we say don't simplify, but this is multiple guess, so we kind of have to. So what do you get here? Negative 1/8 plus a half. Common denominator is 8, which makes that a 4. We get negative 3 over 8. Oops, sorry, positive 3 over 8. Don't tell anybody I did that. So the answer is just D. Hope you enjoyed the video. I will see you.